Hi, my name is Mars, and I'm presenting for the group of Jiangqi, Yihui, and I. And our study is about reproducing and verifying diffusion-GAN, aiming to enhance GAN training with multi-step diffusion process. Generative adversarial networks and diffusion are some of the most important and popular image generation models. However, they face generative learning trilemma on the right, which is balancing high-quality sample generation, fast sampling, and maintaining diverse and comprehensive model coverage. Additionally, the stability of GANs during the training is a significant concern. So improving GANs and diffusion models has applications in various domains such as entertainment, medical imaging, autonomous vehicles, and more. So in this study, we researched on the specific and novel approach to train GANs with the multi-step diffusion process, as described in the Diffusion-GAN framework. So our research focuses on these three tasks: re-implementation of StyleGAN 2 and projected GAN as the baseline model for comparison. Second, we verify the performance with and without diffusion. Lastly, we implemented and experimented with additional diffusion to the latest StyleGAN 3. And our dataset includes CIFAR10, STL10, and FFHQ. So the first two being images from everyday objects like birds or cars in lower resolution, and FFHQ is a high resolution human face dataset. And this dataset aligns with the common usage for image generation tasks. Our research is based on the paper Diffusion-GAN, training GANs with diffusion in June 2022. We focus on three GAN models including StyleGAN 2, projected GAN, and ICLR. And to verify the effectiveness of diffusion process in GAN, we ran comparison training for each GAN models with and without diffusion. And for each group of models, we also used. And second, we experimented with introducing diffusion noise to existing StyleGAN 3 model, which is not used in the original paper. So to quickly introduce how the diffusion noise is added to the GAN model, we're starting with the original StyleGAN 3 model with generator and discriminator. And the goal is to adjust the difficulty to train discriminator D hard enough to prevent overfitting, but also not so hard to prevent learning. So then, depending on how much discriminator can differentiate between created data and real data, we can modify the intensity for the diffusion process. And the results of our experiments are measured in Fisher inception distance, FID, which quantifies the distance between a generated image and a real image. And the lower it will be, the better. We will face some difficulties to implement ICLR without diffusion, but all other models have shown improvement after introduction of diffusion process. Starting with StyleGAN 2, the diffusion process converges slower but achieves a slightly better results of 3.48. Surprisingly, we are not able to achieve the FID of 3.1, which is denoted in the paper, even after 230 iterations. For projected GAN, we see a bigger performance gap between the original and diffusion model, which is 7.45 versus 12. Finally, for our novel diffusion StyleGAN 3 models, the diffusion model also converges slower but achieves a slightly better results of 11.15. It is important to note that we are running the same dataset as StyleGAN 2, but none of StyleGAN 3's model come even close to the results of StyleGAN 2. This leads to our conclusion that we verify the effectiveness of lower FID with diffusion, but at the cost of slower convergence. We are also skeptical about the results mentioned in the paper, even after hundreds of iterations. And we experimented with the latest StyleGAN 3 models, but didn't outperform the previous version of StyleGAN. And one reason being these models are intended to run on dataset with much higher resolutions, and therefore we believe experimenting with larger dataset and extra model tuning will be crucial for future work. Thank you.